Hello, all. Good morning or good afternoon, depending on what time you're watching this. So this is Islas Ahmed Nawaz again, just going through another demo end to end. So today's demo, I'm just gonna walk through an AI firewall that I essentially created. So if you run any, AI agents in production, one bad loop can burn hundreds of dollars or pounds against your open AI key before you notice. And this is essentially a firewall that stops that. So it sits between your agents and open AI that actually enforces a hard per agent daily budget. So you go over and the request is refused before it ever costs you anything. So I'm just going to be walking you through this today. So as you can see, this is our the pretty dashboard that I've created. Um, so yeah, so let's walk through. So I'm just going to show you how a normal request works first. So as you can see, you've got this. So essentially, as you can see in here, you've got you point any agent on the firewall. Um, you know, you swap the base URL, add agent ID, um, and essentially all this a normal request goes through, and this is a real OpenAI cost, and it costs a fraction of a cent. And I think the real content essentially is, as you can see, you got clean 200, so the real um as you can see here, you've got a real open AI response which says, "Hello, how can I assist you today?" So in the content field, 18 tokens total. So the fraction of a cent, essentially. I think that's the one thing to actually pinpoint for this one. The content string. So as you can see, the JSON scrolls out, and you can see that review here. Um, so yeah, so I think that's one of the main things. And so it actually proves the request actually reached OpenAI and came back, which obviously sets up the contrast when SHA-2 gets refused. So yeah, so kind of going through the next one. So let's say when a halted agent gets cut off. So this is, I call it the money shot. So as you can see here, yeah, so budget exceeded, agent execution is halted. So yeah, that's what this. So essentially, this agent already blew through its daily budget. So as you can see, watch 402, budget exceeded, the agent execution halted. So that request never even reaches OpenAI. So I've just got a runway loop that just dies right here. So the main thing to pinpoint here is the 402 body. So the error, budget exceeded, agent execution halted. I think that's one of the main things. Um, I'm going to try to hammer it now. Is one of my requests. So as you can see, it doesn't matter. So it doesn't matter. As you can see, it doesn't matter how many times it tries. Or it retries 402, 402, 402. It's going to be cut for that day. So I think the main thing to pinpoint here is obviously the that 402. So if I just run npm test, you can see, yeah, so this is all yeah, it's very, very thoroughly tested from my side. So now I'm just gonna go to the dashboard, and as you can see, so here's the operator view. You've got the demo bot in red, halted, 14 days of history per agent, and obviously an export CSV file. I think that's the main thing to see. So you got the red halted row, and then you got the history chart, and then to the export CSV. So I'm just gonna kind of that. So that's from a UI, from the UI UX experience. So I'm just kind of gonna go through the files now, just to kind of give you an understanding of exactly how I actually created this. So here's this is just the README. Let's put this down a little bit. So here, as you can see, you got the ASCII diagram, agent to AI firewall to the OpenAI. So this sits between the agents and the OpenAI. So obviously, the GitHub is linked in the will it be in the YouTube and description, and you'll also be able to access it through my LinkedIn. Then I'll go into my Redis. So here, this is essentially. So I'll see the halt, defer, and OK returns. So this LUA's well, this Lua script essentially runs autonomically in Redis. So you've got two requests that can't both slip past the limit, no matter no, so essentially there's no race condition here. So that's one thing to make sure that I make sure I Yeah, so make sure that I'm highlighting here, as well as in here you've also got a budget dot reserve as well. Yeah, you got budget dot reserve as well. So here, what you do. Oh no, it'll be in the chat. The source root path. Yeah, so it'll be budget dot reserve. Yeah, in here as you can see, you got the budget dot reserve, and then it's gonna go into the status equals hold, and then you're gonna see a res status 402, and this is the line is gonna be. This is the line essentially that retains the 402 that you just saw on the demo. The three keys, going back to the README, is the the SK, and you've got the PK, and you've also got the AK as well, and that's essentially all that is agents never actually touch the real open AI key. If you leak, obviously you can imagine, right? If you leak the proxy key and then you lose a capped daily amount, it's not your account as well. So I think that's the, that's the scary part here. If I go into the security markdown, so I've been quite explicit here with what I'm trying to do. So this is essentially the pen test finding table. So I actually pen tested my own code, and I obviously found real bugs. So like a negative max tokens that corrupted the budget counter. That was something that I did fix in the commits, and that's something that you'll be able to view in the GitHub repo, as well in the commit, in the commit history. Um, in the so I'll just go through the pen test. The fix, obviously, you can see the number 6. Well, for fix no 1 to 6, there were quite a few things that I did fix. These are just some of the bits and bobs, as you can see. So this is fix 1 to, yes, from yeah, so 1 to all the way to fix 6, right? So yeah, as you can see, when I run npm test, this is, yeah, as you can see, all cool. Let me extend that a little bit. So, yes, I think that's something to highlight. So, all of that is green light there. So, I'm very happy with that. So, essentially, every fix, ships with a test that actually proves the exploit is dead. So, it's 52 passing. From a Docker point of view, so I've got the Docker compose. I'm just going to try to quickly touch on this, as well as the YAML file, the CI YAML file. So this Docker compose, and then I've got the close this. Got the Docker compose, and then I've got the YAML file as well. So in here, CI YAML. Yeah. So all of these, they've got linting, testing, all the Docker jobs. So one command to run it. So the CI tests and builds a container on every push, and that's essentially end to end. So this is the firewall. It is essentially an atomic budget enforcement, um and yeah, I think there's atomic budget enforcement in Redis. It's pen tested with a test for every fix, and the link and code will be obviously in the in the description. So I did use node JS as obviously the proxy runtime, and this is obviously you see in the chat. um, and you can see that in the chat and in the redis.js. um that was the main thing. So it was just node, not node and express. Of course I also use redis and lua, so the core of the whole and I think that's the core of the whole thing. The reserve lua and the commit lua constants in redis, I think they were, as you can see, the proof. So the reason lua matters and the line with landing, I think the main thing that I'm trying to make sure that it lands is that the reserve check and decrement checks as a single atomic script inside of Redis. So there's two concurrent requests that can't both read budget. Okay, of course, before either write suspend. So I think that's the race condition our naive get then set would have, and I think is why this isn't essentially a toy. This is the one place to actually, that actually, I want to iterate. Also from the reserve commit ledger model, it's not a library, but it's actually an architecture I want to make sure I emphasize, as part of the stock, because a worst case estimate up front, you're gonna have to commit the actual cost after the OpenAI course. So there's two incredible float ledgers in, you know, so yeah, as you can see here, incredible flows, um, and I think that's one of the things in Commit Lua, pay agent and fleet wide. I think that's essentially what it lets that is what lets the cap hold even when a real token usage is unknown at request time. From the Docker point of view, you can see. Let me just go into the YAML Docker compose YAML. So in here you can actually see that for local Redis and the Docker job in CI, this builds a container. The GitHub Actions, I did obviously touch up on it just briefly, but again, there's three jobs here. You can see there's linting, testing, and the Docker and tests, and this obviously tests and builds on every push. Railway, that is what I've used as the deploy target. It's in obviously in the base URL. Essentially, it's a plain JS dashboard. There's no framework, and and that's a feature in itself. It still does real work. So there's 14-day history. There's nothing in the eight stop file tool, which I actually mentioned. That actually. So there's obviously 14-day history, hover tooltips, CSV export. You can see here in the UI. And that's the main thing. It's lightweight, but it's not underpowered. Um, I think the main thing is right. It's built deliberately lightweight. So we've got Node.js proxy, we've got Redis with Lua for the atomic budget logic, and we've got a plain JS dashboard, and it's all Dockerized on Railway with GitHub Actions CI. So there's no heavy frameworks. Yeah. So thank you for watching today. This has been Islas Ahmed Nawaz. Please leave a like and a comment on your thoughts. Thank you all.